Okay, so what I'm going to do is talk about a couple of other multiplicative functions. I'm going to talk about the Liouville function. Liouville function, normally written lambda of n. Well, if n equals p1 to the alpha 1, if this is the prime factorization, pr to the power alpha r, then lambda of n equals minus 1 to the power alpha 1 plus alpha 2 plus alpha r. So it's the number of prime factors, counting with multiplicity. And this is pretty obviously multiplicative, because if mn equals 1, mn equals 1, so of course m equals p1 to the alpha 1 through pr to the alpha r, and n equals q1 to the beta 1, qs to the alpha s. Then you can quite easily see that lambda of mn, lambda of m, lambda of n, just lambda of n, just by the properties of powers, really. So that's a nice little function. That's multiplicative. Comes in handy. There's another thing called a mangoldt function. Mangoldt. I think that's is that a lambda or a gamma? That one. That's a. I think that's a capital lambda. Lambda of n. Okay. And if n equals, well, lambda of n equals two things, 0 or log p. And it's log p if n equals p to the k, for p being some prime. K is greater than or equal to 1, and 0 otherwise. That's a stupid way to write it. Let's write it out again. Equals log p if n equals p to the k, so prime power, and 0 otherwise. And you can verify that this is multiplicative. Okay, I'm going to stop there.